Hello and welcome to the first e-organic webinar of our third winter season. Today's webinar is called Can We Talk? Improving Weed Management Communication Between Farmers and Extension, presented by Sarah Zwickle and Marleen Riemens. Also joining us during the question and answer period will be Patrick Lillard of Purdue University. My name is Alice Formiga and I'm the webinar coordinator for e-organic. E-organic is the organic agriculture community of practice with e-extension. You can find all of our published articles, videos, and our many recorded webinars on organic farming and research topics on our website at extension.org/organic_production. This presentation is being recorded, and next week you'll be able to find the recording on our website and on the eOrganic YouTube channel. Before we begin, I'd like to briefly introduce our speakers. Sarah Zwickle is a research assistant at the School of Environment and Natural Resources at The Ohio State University. Her master's research on the weed management decision-making process of organic farmers served as the foundation for the extension and outreach efforts of the OREI project, Mental Models and Participatory Research to Redesign Extension Programming for Organic Weed Management. Marleen Riemens is a weed scientist at the Wageningen University and Research Center in the Netherlands. For the past few years, she has been researching the relationship between weed pressure on organic farms and organic farmers' weed management behaviors and beliefs. Patrick Lillard, who will moderate the questions after the presentation, is an educational program specialist on this OREI project with Marleen and Sarah. His role on the project has been to develop communication and outreach for organic farmers based on their mental models research. After the presentation, which will last about 45 minutes, we'll have 30 minutes for answering questions from the audience.
Hi, my name is Sarah, and I'm glad you all could join us today. And I will be talking about my involvement in this project that I was lucky enough to be a part of. I have a background in farming as well as a researcher. My family farms in eastern Washington, wheat and alfalfa, and so I am a transplant to Ohio. I am not a invasive weed, however. And I've been enjoying learning about the corn and soybeans and all of the great organic farming in the state. So let me just start. Make sure I have, there we go. Go back one. There we go. I wanted to bring up this slide first. I found this in the USDA archives. It's an old farmer's bulletin from the USDA from 1915, and it's very apt for our study today, almost 100 years later. And they're talking about weeds, and whenever there's weed in a field, then a farmer needs to make a decision. And a lot of times those weeds are viewed as enemies. I love this, enemies in reducing crop yields and multiplying labor. And that everything a farmer does, Cox writes, should be centered around these weeds: what crops he will grow, the implements he will use, what seed he will buy, all the things that you will see are studying in this project today. And I love this last quote: hard work and plenty of it must be observed, but unless the work is applied intelligently, lots of labor and time might be expended with little accomplished. And so what we're talking about today is exactly that, a combination of weed science and biology, as well as farmer decision making and intelligence. So our main research questions when we came to this project, and it's funded by the USDA, it's the OAREI, Organic Agriculture Research and Extension Initiative. It's a 4-year project. And basically you observe that there are a lot of sort of barriers between the organic farm community and land-grant universities and their communication and collaboration in the United States. The history of this is sort of due to many factors, but they're just traditions they're just two different traditions. And I think what we wanted to do was figure out how we could improve communication between organic farmers and bigger universities and extension outreach. And we also knew that there's a lot of research out there about how to manage weeds without chemicals in organic systems. We focused on ecological weed management practices. They're well known and written about, and yet farmers are still struggling with weeds, and we want to figure out what are the obstacles to successful implementation of EWM, both communication-wise and just implementation-wise. So how are we going to answer this question? We use a methodology called mental modeling. So really briefly, a mental model is when you're confronted with an object, like in this slide, say you're confronted with Canada thistle. Um, we interpret that object and visualize it and make sense of it through something called a mental model, which is basically an internal representation of the world. It helps us to make decisions about that object or thing, in this case weeds. It helps us to solve problems, and it's very practical. And oftentimes our first reactions, our first part of that model is emotional and from our gut. So the very first thing this farmer thinks of is any expletive you would like to fill in there. And the second thing after that sort of subconscious level is a more deliberative and analytical side of our thinking selves. So what is it? Where is it? Might compare it to my weed populations last year and maybe how I'm going to handle it or manage it. So a farmer model is very practical. Um, we're also going to explore the expert model of weed management. And that's going to be slightly different, usually theoretical in nature. So when experts or scientists or researchers are thinking about weeds, their representation is maybe more complex. They might be thinking more about biology. It's much more objective. Maybe phenology, how it reproduces, all of these sorts of things. And it might be more complex than a layperson's mental model, although we'll talk about that a little bit later. So this methodology is meant to help improve communication, actually, because if we start with a layperson's mental model, the intended audiences, in this case the farmer's knowledge and beliefs and perceptions about a weed, then you don't waste time in communicating things that they might already know. And you can also, rather than prescribe a best practice, you can create communication that is more informative for the audience because you understand what they already believe and perceive, and you can provide them with information that they need to know so that they can make their own informed decisions. So that was the rationale behind mental models. And what we did was we went out and we generated a farmer model and an expert model. We did several interviews across the United States and California. I did mine in the Midwest, in Ohio and Indiana. I did 29 on-farm interviews, which were fantastic. And then we did some in New England and the Netherlands as well. And Marleen will be talking to you more about those later on in the webinar. So I'd like to show you how you generate a mental model. Like I said, the interviews. Once the interviews are done, you transcribe them into a software program that is a qualitative-based software program, and you code each interview line by line in order to uncover sort of the themes and the concepts and the categories that are most important. One, to the experts. I forgot to mention that I also interviewed 16 experts in weed science and ecology, as well as extension personnel. So you code all these interviews line by line, and then you can visualize these codes into diagrams and tables. And really briefly, I want to just go into a little more about how that works. For instance, you can see in this table, there's a hierarchical structure. There's going to be 5 main categories in the models. You'll see that coming up. One of these categories is the benefits of weeds. And in the first column, you'll see that 100%, this is the expert model, experts speaking here, 100% of the experts agreed that there were benefits to weeds. They mentioned these benefits in the frequency column 174 separate times. And then the last columns is where I talk, represents what percentage of the time of the model this category is. So of the entire model, the benefits of weeds is 12% of the entire model. And as we go down further, the benefits talked about are agricultural in nature, 83%. You can see of the experts agreed. They talked about that 73 times. And 42% of the weeds benefits were agricultural in nature. You can see here 60% of those benefits were related to soils, and so on and so on. 27% of those soil benefits were erosion related, and you keep drilling down further and further into the model. So that is how it's generated. Let me show you an example of the expert model. as a diagram to the greatest level of detail. Let me go down one here. For some reason, it's not going forward. Let me try one more time. Let's see. There we go. Okay, this is the expert model. It's a little fuzzy, but this is visual. This is a diagram to the greatest level of detail, and you can see what I want to talk about here is that even when interviewing about something as focused as weed management, when I talk to the experts, this is their mental model of managing weeds, and you can see just it's very complex. This rectangle here is the weed management decision. So all of these ovals before the weed management decision are all the factors that you could take into account before you decide what management strategy to use. And all of these ovals after the weed management decision are all the possible weed management practices that a farmer could engage in an organic system. So right up front, you can see this is complex. And that's because we're talking about two systems at the same time. We're talking about the agroecosystem and weeds within it, as well as the human decision-making system. And so the model is going to be pretty complex. Let me show you the next slide.
Unmuted.
I'm just having a
Hi,
little
Sarah.
trouble going.
Just try to click on the screen once to get it going again.
Yep.
See if that works. Otherwise, I can
Okay.
advance the slide for you, but just see if you can click on your screen. Is it not
Yeah,
working?
I did. It's not working.
Okay, I'll advance the
Go
slide
ahead
for
and
you.
advance it.
Okay, sorry about that.
Thanks. Okay, so here's the expert model in a simpler version. It's the same model, only the categories and the concepts are consolidated. So you can see
Muted.
there's 1, 2, 3 main categories before the weed management decision and 2 post-decision. Farmer attributes and farm attributes are the main categories that influence how a farmer perceives weeds and weed management. This is the expert model, what the experts are talking about. And the management decision, we split into 2 different concepts. The first one is critical weed-free management, which is mechanically based and happens after the weed seedling emerges. And then the seed management is on the other side of this continuum of practices because we recognize that farmers will be using both. Seed bank management is focused more on long-term strategies like cover cropping, crop rotation, mulching, and is usually more culturally based and happens before the seedling emerges. Now the shading tells you about the frequency of mentions, so how often an expert or farmer mentioned this category or concept in the interview. So tillage and cultivation were very salient in experts' minds. The more frequently something is talked about, the more salient it is in a mental model. Another thing of note is that weed risks and weed management risks were talked about more than weed benefits and management benefits. Okay, I'll try to go forward myself. There we go. I just wanted to show you the expert and farmer models side by side real briefly for some comparisons between the two. So these are the results that we got after all of our interviews. Let me see if I can you scroll forward for me? Alice, can you go forward one? I don't seem to be able to do it. There we go. So the most salient concepts between both of them were the tillage and cultivation management practices. Farmers, you can see here, talked more often about cover cropping than experts, and pre-management decision, farmers talked a lot about the resources they have available to manage weeds. Also of note is that the risks of weed management, agricultural, they're split into 4 different concepts: agricultural, economic, ecological, and social. These risks are very similar between both models, although farmers placed a bit more emphasis on soil health, the risks of management to soil health, while experts talked about ecologically based risks for management. And one more comparison here. In the farmer attributes category, values were talked more about by farmers than experts as part of what makes up their weed management decision. And there were two extra concepts that farmers talked about, which experts didn't. Those included seed bank beliefs about things like 1 year's weed to 7 year seed, that weed seeds can live quite a long time, many, many years or forever in the soil. And also the belief of indicator weeds, which is that weeds are an indicator for nutrients missing in the soil, and that adding those nutrients would mean that weed was no longer needed. And so for instance, if there's thistle in your field, it's trying to bring up calcium because the soil is low in calcium, and if you add that calcium, then the thistle won't be needed and won't be there anymore. And that's something that experts were aware of but didn't talk about as much. Okay. Another way of showing a mental model is just using bar graphs, and this makes it really easy to see that farmers and experts talk about risks and benefits of different management practices really similarly. They're almost identical. And this is interesting because, on the next slide, because in these two mental models, the expert model and the farmer model, there's sharp alignment in almost every category and even every concept, which is very rare for mental models research. Usually the layperson model will show, usually there's quite a few gaps between the two models where you can target different communication messages to sort of bridge those gaps. But in these two, there's not a whole lot of gaps, and the explanation for that, of course, is that farmers are experts in their field, literally. So we're back to our question then. If the two models are the same, if farmers have quite a bit of ecological weed management knowledge, which they do, the model shows that, and the risks and benefits are perceived about the same, then why are weeds still such a problem? And this is where I bring in some of my background in decision sciences, so how people are making decisions. And two possible explanations for the reasons why it's still difficult to manage weeds successfully. One, the constraints that farmers are making decisions under, such as time and labor. And then two, the ecosystem is really complex. So when we're confronted with something like a weed and we're trying to make a decision under constraints and complexity, humans, including farmers, are going to try to use shortcuts, rules of thumb, different heuristics to make those decisions easier. And these sort of shortcuts might not be in line with sort of longer term reduction of seed bank. You know, the goals of EWM are to overall reduce your seed bank so you don't have as many weeds in the future, but quicker decisions might not be in line with those sorts of outcomes. So let me explain a little bit further. On the next slide, really quickly, decision science today says that humans use dual processing when they make a decision. So in other words, we're not just robots that analyze everything completely rationally. We also use emotion and experience. This is especially important for farmers, this experiential side, which is system 1, and deliberation is system 2. And we rely on this system 1 to speed up our decisions, and the system 2 to help us make more deliberative and sort of long-term decisions. So they both work in tandem. And the next slide, I'll speed this up a little so Marlene's got time. So we wanted to know, are farmers using system 1 or system 2 processing? So we gave them 16 note cards based on these two systems that asked what are the most important factors when you're making weed management decision. For example, experience or what worked in the past would be system 1. Latest science and research would be system 2. And we asked them to work quickly to rank them from the most to least important. And here are the results. This next slide. The top 4 ranked decision factors, what worked in the past, you can see here, 3 of them are system 1. In the next slide, the bottom 4, it's hard to see that, but the bottom 4 factors, latest science and research, and this bottom one is extension recommendations, were the least important in making weed management decision. 3 of those 4 were system 2. Another way of looking at it on the next slide is that out of the top 8 most important factors, and you can go one more, Alice, for me. out of the top 8 most important factors, most of those were system 1, and then as you get towards the bottom, you see that those rely more heavily on system 2. So let's do a little bit explaining. So why are farmers using system 1 and what does that look like? Well, system 1 involves emotion. I talked about that a little bit, or affect. We asked farmers, what's the first thing that comes to mind when I say the word weed? And 95% of their reactions were negative. So that can lead to sort of emotional reactions that either enhance uncontrollability and dread, or you might not have any affective reaction at all, and you wouldn't have any motivation to do anything about a weed. So like newer farmers, for example, who don't have a family history of farming, who are new to maybe urban farming, might not have a very negative emotional reaction to weeds because they're just not familiar with them. And so they might leave them in the field, for example, because they're part of the agro-ecosystem, and that's probably going to come back to haunt them later when they have to spend a lot of time hand weeding vegetable beds. Or if you overreact to a weed and have a high risk perception, you could end up spending too much time and labor on it when you don't need to. So that's one example of how a system 1 shortcut could lead to a detrimental decision. In the next slide, there's another thing called strategizing, which means that you make a decision based on what's most important to you. So maybe a farmer is more concerned about economics than a long-term crop rotation, so their decision is satisfied on economics. Or perhaps a farmer is satisficing on the equipment they have rather than what's best to do in order to reduce their overall seed bank. And this next slide talks about trade-offs. So of course farmers are going to have different values when they come to a weed management decision that are probably going to be in conflict with each other. For example, should I choose to have totally clean fields, which means more time and labor because I want the public perception of my farm to be good? Or can I stand a few weeds in my field because it's not going to hurt my overall yield, but my public perception might be a little bit lower? So that's trading off values between clean fields or yield or weed thresholds. And one of my favorite quotes from one of the farmers was their value of ecology versus economy. So I'm going to read this for you. Her neighbor asked him, why aren't you cutting hay? Because everybody was done cutting hay. And this farmer had the lame excuse that the bobolinks were nesting. Bobolinks are nesting, I said. And his neighbor said, well, you don't worry about bobolinks. And this farmer said, well, yes, I do. So that's an example of somebody who's valuing ecology over the return on their hay. So real quickly, I think I'll skip the slide and go to the next one, which is the conclusions, because I want to give Marleen a chance for her time. Farmer knowledge is management or system 1.
Unmuted.
Because like researchers and scientists, farmers are keen observers of how their management affects weed populations. So when talking to farmers, it would be more direct and relevant for them to focus more on management-based causes and solutions rather than ecology. And also, farmers have really strong risk perceptions in relation to soil health. And risk, when you view something as a risk, it points to what you value. And of course, farmers value soil. So any outreach, on the next slide, I think I say any outreach to organic farmers really needs to be framed in terms of soil health, and to recognize that organic farmers are cultivating perhaps a lot, but that they have a very nuanced skill with cultivation and tillage and understand and watch how it's affecting their soils. So to recognize that skill and that value, and also to research the shortcuts that farmers want to do. So if farmers are interested in weeds as indicators, to research and provide them with evidence-based evidence, just to provide them with evidence about that, so that if they need to make a quick decision based on weeds, to tell them if that is actually going to be in line with long-term goals, if it actually works. To emphasize seed bank strategies as saving time and labor because they're under such rigid constraints. And to basically just provide them with sort of cheat sheets to be able to make quick decisions without compromising long-term goals of soil health and economic viability. And the last thing would be to conduct on-farm research that matches the way they like to learn, which is through trial and error and experience. And with that, I'm going to hand over because one of her major talking points. And here's my information. It'll be on the PDF if you have more questions for me. And thanks for listening.
Okay, Marleen, I'm going to give you control of the screen, so you should have it in just a moment here. Okay, so if you just click on your screen to get it activated. Okay.
Yep. Oh, it's going forward. Okay. Well, thank you.
Muted.
Indeed, I will be talking about weed management being more than technology, and I will focus on the importance to include the farmer in the research. And I will give some observations from our research in the Netherlands on this subject. But first, I want to tell you something about my country, because many of you may not be familiar with it. The Netherlands is located near the North Sea, to the west from Germany and to the north of Belgium. And across the North Sea, you have the UK. We have a densely populated country with almost 17 million inhabitants now, and a total area for agricultural land of, well, about 1.9 million hectares. And the total area used for organic farming is still quite low, 55%, 55,000 hectares, which is about 3%, but it's increasing with 10% per year now. So a lot of people are shifting from conventional to organic farming. And when we look at farm sizes in the Netherlands, which may be a bit different from farm sizes in the US, we can see that an average size conventional farm is 26.4 hectares and an average organic farm will be 36.5 hectares. And just to give you an idea of our cropping systems, you can see this graph here with a division into the use of agricultural land. And you can see that the majority is grassland, so that's 64%. And this is also for a large part used for dairy farms. The other 36% consists of cereals, fodder crops, fallow, AGF crops, which are potatoes mainly, carrots, onions, peas, and cabbages. The other crops, the category other crops, are, for instance, flower bulbs, greenhouses, and orchards. Yeah. So we have a typical crop rotation of 1 out of 4 to 7 years. So once every 4 to 7 years, sugar beet is grown, or summer wheat, carrots, peas, consumption potatoes, grass, clover, and seed onion. And this is a typical rotation on both the conventional as well as an organic arable farm. So that was very shortly an introduction to the Netherlands and the farming systems we have. And now I would like to tell you more about agricultural knowledge development and dissemination and how it's organized in our country. Actually, we can identify several institutions, so ways in which people can interact, which have been or are active right now while dealing with agricultural knowledge. So we have this so-called OVO model, which I will explain a little bit later. We have, of course, green education, so schools in which farmers are educated. But we also have knowledge vouchers. So if farmers or companies have research questions, which they want evidence-based research for, they can apply for knowledge vouchers, and the government will provide some money to investigate this research, this problem, and they can hand in this voucher with every research institute or university they want to. Then we have some regional knowledge centers and regional knowledge managers. So all kinds of institutions working at several types of levels. But when we are talking about knowledge development and dissemination, it's important to keep in mind that there are 3 general types of innovation affecting not only development of knowledge but also the dissemination of knowledge. And these 3 are the following. So we have this linear model, which is science-driven. It starts with fundamental research, which hands over their knowledge to applied research, to adaptive research. Then it gets to extensions, and experimental farms, and then finally it should be applied by farmers. So it's really a very linear model. There are some loops going back, but they are not important. The main line is from fundamental research to application in practice. And then you have this chain link model, which is more demand pooled. So you have many feedback loops there between innovation, testing, redesigning, distribution, production, and marketing. And this is also true for some agricultural systems. You also have here the linear line within the chain link model, but the most important part of the model are the loops back, flowing from practice to research and back again. And then you have the participatory technology development model, in which farmers are in control. It's more adaptive-oriented research, which has strong emphasis on local knowledge. So I mentioned the OVO model. It was a model which was active and for some part still is in the Netherlands from 1880 already until the 1990s. And the OVO stands for Research, Extension and Education. So this model is a linear model, which is research-driven with little amount of loops going back from practice to fundamental research again. It was initiated in the 1880s after a food crisis, and during the decades afterwards, it developed into a larger system in which systematic research programs were carried out, all under the auspices of the Ministry of Agriculture. So this whole system finally consisted of one university, which was Wageningen University, 34 research institutes, and 49 regional research centers. And the main thing about this model was that it was containing a lot of systematic research programs. And actually it was highly successful for almost 100 years. And the high days of this model started after the Second World War, so it had a slow start, but then it was widely accepted and used. And the reason was that food shortage during, but also in periods prior to the war, were a big problem, of course. Another reason was that the awareness that agriculture was a field in which scientific principles could contribute to the improvement really rose. So the reason for this linear OVO model to work and work for so many decades was that there was a clear common goal. The goal was to increase production volumes, lower the costs, and improve quality. So you can see this graph here, which reflects the success of the system. So you see the wheat yield per hectares from the early 1960s until, well, almost today. You can see that yield was almost doubled. So, of course, there are other factors, but in the Netherlands we tend to think that the system was really effective and worked. But then, in the 1990s, people became more aware of global changes and different demands that were asked from the agricultural system. So we didn't have the problem of food shortages anymore. We had all kinds of problems associated with intensified production systems, such as overproduction, the environmental problems. And there was this global demand for more liberalization and diversity of markets, not only in agriculture, but it certainly influenced agriculture. So innovation became more and more a responsibility of the market itself, and not the government, was the overall thought in society. So the mind shifted from a linear science-driven system more to a chain link model, so more demand pooled system. And what was really important, the clear and especially important common goal was not longer there. So increasing production was not as important anymore. So what happened during the 1990s and is still happening today is that the government responded to these developments by privatizing a lot of public services, such as the railroad company, postal services, but also agricultural extension and part of the research institutes. So the importance of knowledge development in agreement with markets, but also in agreement with farmers, gained interest, and participatory technology development models were installed. So instead of determining the research programs, scientists now act as participants in networks of farmers, agribusiness, and the public sector. So it's now more a research demand pooled system instead of a very linear system. Or we are going more to this system. So, and if you look at the basic rules for research in demand pool systems, then there are actually two that are very important. First is understand the system in which you participate as a researcher and be aware of your role. So, and your role is problem observation and methodology development. So for us as wheat scientists, it is becoming increasingly important to understand the system in which we work. And for that reason, we started an explorative study in 2003 on wheat management systems. And we started we tried to investigate the farmer beliefs on wheat management and wheat management behavior, identify the problems farmers encounter, and link that outcome to the behavior, so in this case the wheat pressure. I will tell you a little bit more about this explorative study now, because it was for us the reason to join this OAREI project. And we had in this study the specific question of, can we relate wheat pressure to wheat management behavior? Can we relate wheat pressure to farmers' beliefs about weeds and wheat management? And can we relate wheat management beliefs to wheat management behavior? We started very small. We had the approach to include 16 farmers in our study, and we investigated wheat pressure on the farms, so wheat seed production and wheat density prior to harvest. So this wheat pressure was the result of the wheat management tactics the farmer applied, and we investigated the application of the type of management strategies. So were farmers using EWM or more cultural wheat management systems, and we looked into the beliefs on weeds and wheat management when we interviewed farmers. And what we found was that we could relate wheat pressure and we could explain it by management behavior. And two management activities were really important in explaining the variation between farms and wheat pressure, which was the timing of the main soil tillage treatment, whether farmers would plow in spring or in fall, and the number of applied preventive measures. And the number of applied preventive measures are actually all EWM strategies. So plowing in autumn prevented seed production during winter and early spring of abundant species such as Stellaria media and Poa annua. So for a large part of the farms, it really paid off to plow in autumn instead of spring. Another thing we found was that farmers who applied a lot of preventive measures, so EWM strategies, targeting the seed bank, so changing their crop rotation so that they could apply still seedbed preparations or use a competitive cover crop, also had lower wheat pressure on their farm. The next thing we found was that wheat pressure was related to farmer beliefs. You can see here a graph on the beliefs on soil structural damage, and Sarah also told you that soil structure is important as one of the perceived risks of wheat management, and we also found that in our very small study. You can see the wheat density on the y-axis, and then on the x-axis never, sometimes, and often as categories. So farmers that often think, well, I'm not going to control my weeds, although I think it's necessary, but I'm afraid that it will damage my soil structure, have higher weed densities than farmers who think, well, I'm not afraid of soil structural damage and I will just go and control my weeds, and well, they are lower. You can see that reflected in this graph. And the other one was what we found was that farmers differed in their beliefs on the importance of long-term strategizing. So there was this group of farmers, almost 50% of the farmers we interviewed, who said, well, I think the short-term cash flow is very important, and I will adjust my crop rotation when I see that market prices will probably be high for certain crops this year, although it might not be the best solution to grow these crops for my system, so for the ecology in my system, for balancing my system. While other farmers said, well, I don't look at market prices at the beginning of the season. I have a very good system which works in the long term. So these farmers were more long-term rotation oriented. And you can see this in the graph with the question, what kind of grower are you? Are you more market oriented, or we call it here crop growth oriented, so long-term oriented? And then you see that the average density of weeds was a lot higher for farmers who were focusing more on the short term than on the long term. So in this study, we saw that the weed management beliefs were related to weed management behavior, and that long-term oriented farmers who had low weed pressure grow different crops from farmers that are more short-term market oriented. The long-term thinkers grow more competitive crops, such as cabbages, potatoes, cereals, grass, legumes, which have lower yields in euros or dollars. And the short-term market-oriented farmers grow more crops with less competitive qualities, such as flower bulbs, onions, sunflowers, pumpkins, but which have a higher yield on the short term. So we concluded that it's very important to look at this human dimension while you're doing research, because it can lead to a better understanding of the organic farming system, but also lead to more effective communication on weed management in those systems. So it was our first step to understand the system where we work in as weed scientists. Now I want to shortly give some results of the Netherlands within the current project, so the project Sarah talked about, the mental model project, and results that we found were quite similar to the Midwest. The knowledge of experience-based ecological weed management principles were also very high for the Dutch farmers, and they also mention a lot of external farm constraints as a barrier to apply these strategies. In addition to the Midwest, however, farmers indicate that they need more knowledge, that they really lack knowledge on a species-specific level. So they want species-specific ecological weed management strategies. And this actually requires more experiment-based EWM knowledge. And some of this knowledge is just not there yet. We don't have it, so the research cannot provide it yet. So this is an important signal from this project, in my view, towards research and extension. Farmers are struggling with these questions. So I have this specific species in my field, and I know that some strategies might be helpful, but I'm not sure whether it will work for this species, and it has a lot of risks applying these strategies. So I'm not sure, and I would like to know how it works for this species. And another thing that was different to the Midwest, or different, but it was really important in the Dutch results, was the no or reduced till systems, because Dutch farmers usually have inversion tillage. Actually, 80 to 90% of farmers have this kind of tillage systems, and they are really interested in how reduced or no-till systems will work. whether these systems will reduce or increase wheat seed banks, because they have all these kind of theories and they see what works with their neighbor and what works on their own farm, but what is the how does it work? That's what they want to know. So Sarah talked about the note cards. We handed over note cards to the farmers and asked them to rank them. In the US, those were 16 note cards. In the Netherlands, we had 13 note cards. So a small difference there, but you can see the factors with an asterisk behind them were not given to the farmers in the Netherlands. But the main thing you can see from this ranking is that it's quite similar, although Dutch farmers give a higher priority to cash flow than Midwest farmers did. And the ranking reflects the importance of soil health in relation to weed management and the search for solutions that require less time and less labor. It also shows that it's important for research and extension to focus on these issues, since current research and extension information is not valued as high for practical management issues. So although I thought it was quite interesting, although we have these different extension models in our countries, or at least we had different extension models, and farmers are working on a different scale, have different cropping systems, they still value the same factors when it comes to weed management. So what you can see here is, again, what we also found in the smaller study, now in this mental model study again, that farmers focusing on maximizing the short-term profit yield higher wheat seed bank densities than farmers who focus on balancing the system more. So again, this short-term versus long-term strategizing seems to be very important. So the division between ecological weed management on one hand and cultural weed control on the other hand. So what we conclude from this project is that the organization of agricultural knowledge development and dissemination is changing to a demand-pooled participatory development model. So it's actually a mix between the chain link model and the participatory development model. And it requires a good understanding of the system we as researchers, but also farmers, work in. The role of research is to observe problems and identify research objectives and develop methodology to answer the questions of farmers, but also industry. And we believe that the mental model development can help us understand this system and develop farmer-driven research. So I think
Unmuted.
to the end of what I wanted to say. Yeah.
Okay, thank you.
And I think it's time for discussion and questions.
Yeah, thank you, Marleen and Sarah. We're about to begin our question and answer session for the next half hour. And for anyone who missed the very beginning of the presentation, we'd like to encourage you to use the question box on your screen to type in questions. You just type in the question and hit return. And if you don't see the question box, you can just click on the small plus sign next to the word question to open it up. And I wanted to also mention that we really value your feedback on today's presentation. So we'd very much appreciate it if after the presentation, you could fill out our follow-up survey, which you'll be receiving in an email in about an hour after the webinar. Also, I wanted to mention that this webinar is being recorded and you will be able to find it on our website at the link on your screen on the next slide. So with that, I'm going to hand things over to our moderator, Patrick Lillard of Purdue University. Everybody will want to unmute their microphone and then we'll move on to the questions.
Okay. Let's see, Sarah, I thought to start off, Marleen had mentioned some of the topics that were really salient to the organic farmers in the Netherlands. What topics came across as important to the organic farmers in the Midwest?
See, we can't hear you. see if we can unmute the microphones here. Okay, Sarah, are you there? And Marleen?
Yeah, I'm here.
Okay.
Yes, I'm here.
Okay, great. Now we hear you.
Patrick, can you ask that question again?
Sure. I was just, Marleen concluded and talked about some of the topics that in both of your presentations you talked about there really weren't those gaps between the scientists and the farmers and their knowledge of weed management. But Marleen talked about that the organic farmers in the Netherlands had
Muted.
specific questions. So I was curious what topics came up from the Midwest organic farmers.
I would say the ones that come to mind first would be they have questions about weeds as indicators of nutrient deficiency in the soil, and if they can use that as a way to read what they need to add in order to decrease that certain weed population. Another one would be how effective is the rotary hoe? I know in the Netherlands they have questions about the effectiveness of no-till, and I think in the Midwest they really were questioning how effective the rotary hoe really was. And let me see if there's another one that I can think of that was pretty. Another topic that came up would just be a lot of farmers in the Midwest were really looking for support during the transition from conventional to organic. Most of that came from dairy farmers who were uncertain about what to expect when they stopped using antibiotics and started going to organic feed, and so there just weren't a whole lot of support materials that could tell them how that transition would go. And those are the three things I can think of right now.
Okay. And then there was a question that somebody had about, it sounds like Marleen's methods. They wanted to know if you looked at pre-existing seed banks at all to make any comparisons, or was it just the weed pressure and seed production of the years studied?
Yeah, that was why I'm also was very happy to join this project because we didn't look at the seed banks prior to the research, but we followed the weed pressure during 3 years, and I think it just gave us a good indication of which farmers had really high weed pressures and farmers who had low weed pressures. Yeah, but we didn't look at the weed seed bank, no. But we did it in the second part, so in the current project, and we see the same results again. So I showed you this graph with market-oriented versus the long-term strategizing farmers and wheat seed bank densities, and we get the same picture. So I think it's okay.
And they also did some of that in New England, and in the New England interviews got very similar results as the Netherlands, relating seed bank densities with the knowledge of EWM principles. So that's pretty cool, I think, to actually combine the social science with the weed science in that way. And the mental models with the weed densities. It's pretty neat.
And there was a question on, another question from Marleen. Did you see any differences between fall and spring tillage on summer annuals?
On summer annuals, we didn't see a difference, no. No. It was really those species that can survive winter periods. We don't have very harsh winters here. Maybe I should tell you that. It sometimes freezes, but usually it's about 0 degrees Celsius. And we have, if you don't till in autumn and wait until spring, you have these species who can survive winter and are already there in autumn and then are not controlled by any tillage, who can survive winter and then produce additional seeds. Well, when you till in autumn, you don't have these species. So it was really about species like Stellaria media and Poa annua, and some Galensoga parviflora. It can also flower and set seed until October, November here. Those were the weeds that were really controlled by tilling in autumn. Yeah. Those are also actually the weeds that are like 70% of the weeds we find in the systems. So Poanua and Stellaria media are the most important weeds here.
Okay, and then a question to switch more to the social side. What implications do your studies have on traditional extension outreach delivery methods, and how best to change our extension strategies to help farmers make behavioral changes?
That's a very big question.
It's the question we want to answer.
Yeah, the one we want to answer, that's right. And I think Patrick could probably chime in on this too, actually, but we've really been thinking and looking at focusing on what the farmers know and believe already. So, traditionally in the dissemination of information type model, you'd come up with these best practices that could kind of apply across farms, especially conventional farms when things are sort of similar in certain ways. But in organic systems, there's such unique diversity that to recognize what the farmer already knows and to start with that rather than starting with what Extension wants to recommend, and creating this sort of dialogue instead of a monologue is kind of what we're going for. So we're really looking at, okay, farmers understand soil health, they have strong values in soil health and family health, and so how can we frame our messages about managing weeds specifically to reflect those values? That's a really important way to sort of shape communication. And we're going to be developing, our next step in the research is to develop these actual communications of, how to say target a certain weed. Especially, I think there's a lot of problems with perennials, and how do we create communication messages around how to manage perennials in ways that show that we understand they value soil health and that weed management is just a small part of their overall systems operations. And we'll be seeing how well farmers receive that information. And then there's, so we'll have results on that. It'll be on, we can share that with you on our website, which is coming up later. But that's what I've been thinking of. I know Patrick and Marleen could probably add a lot to that too.
Well, I jumped in, and that's been part of my project on this grant, is to look at how to take the mental models and develop the extension outreach. And as Sarah mentioned, I mean, there weren't the gaps between the farmers and the scientists, which I think we were initially expecting with this project. And so I think from both the research in the Netherlands and then here as well, it showed that organic farmers have such specific questions that it almost seems we have to have that dialogue and direct communication with them, because I think that might be the only way that they can get their questions answered.
Yeah.
And then somebody else talked about the extension. They said it was quite disturbing how low the ranking was for extension recommendations in the ranking exercise. Do you have any idea why this is?
I think just organic farmers maybe don't view extension, which is connected to land-grant universities, maybe as a trusted source of information just yet. And also just a few examples of when I did ask them, why not? Why aren't extension recommendations something you look to? It's often because they can't find recommendations that have to do with organic methods, or they get frustrated when they speak with a outreach personnel that maybe they don't know as much about it as the farmer does already. So there's sort of this knowledge gap going the other way sometimes, where the farmer needs to know something that the researcher or the outreach personnel doesn't know. Marleen talked about that a little bit.
Yeah, but I think the Dutch farmer said, I think they trust the source and they value the information, only they say it's too general. It's not species specific enough. It's different for farmers in conventional systems, because they know advice on spraying systems, on herbicide dosages is just easier.
Yeah.
The information is available, and they just say, well, we want really specific information for what will work on my farm. So I take it into consideration, but it's not the main factor taken into consideration. So maybe that's also what is happening in your situation. I don't know how it is for conventional farmers in the US and which sources they use, but that could also be a reason for the low ranking.
And then a question.
Yeah, a lot of that's real fast, Patrick. Some of the farmers would say, there are spray guides. There are plenty of spray guides out there about what chemicals to spray and how much, but there aren't any other guides for me because I'm organic and I'm not using chemicals. So they get a little frustrated.
Yeah, it's just a more complex system, weed management in organic.
And there was a question, did you find differences between farmers who own the land versus rent the land?
That's a good question, and we're actually asking that in our survey, which is the next step in this mental models research, is to see if there are any differences between owning and renting. And I only have anecdotes from the interviews. I don't have any sort of statistically based data from the survey yet. Also asking the question, not just own or rent, but if they live on the land versus don't live on the land, if that has anything to do with how they manage weeds. So that's a good question, and I don't know right now.
Okay. Let's see, what was the other? Another question, did I hear you correctly that long-term minded farmers had less weed pressure and grew lower gross income crops, while shorter-minded farmers had more weed pressure and grew higher gross income crops? I guess that was directed at you, Marleen?
Yep, that was correct.
Let's see. Oh, another one. Is there any data on the different strategies for weed suppression? So black plastic around row crops, straw around row crop plants, cultivation, and others.
You mean from this project, from the farmers involved in this project, or in general?
Let's see, there's Kathy. And I was wondering if that was implying another part of our project, which was looking at weed management practices and the levels of weed seed banks that our project is working on, but we don't have any data on yet. Do either of y'all want to talk about that component of the project? Sorry.
Ask it one more time.
No, I was just.
Yeah, what was the question?
Well, I think the questioner was asking about different management practices and if we had any data on the weed pressure. And it just made me think about the other component of our project, which looked at weed seed bank levels and the farmers' management practices.
Yeah, well, I talked very little about it right now, but we looked into it. And if people really want to know the details, they can look into this weed science paper in which it is described. But we found that the application of stale seedbeds, plowing moments, using cover crops, and especially strategies managing the balance in the system, so managing the amount of labor needed spread over the year, really important factors influencing the weed pressure on the farm. I don't know if that was an answer to the question, but
and I guess I could just speaking from the expert model, I'm not a weed scientist, but all of those things that Marleen mentioned as preventive strategies that have to do with longer term strategizing, like diverse crop rotations, having a third of your fields in cover crops at one time, and all of these, mowing or grazing before this weeds set seed, doing your cultivation in critical weed-free periods, all of these things keep weed seeds from entering back into the soil, so that's what reduces the seed bank over time. And I think the experts emphasize that you can actually reduce the seeds in your soil, the weed seeds in your soil, that it is possible with these different EWM strategies. And one of the interesting things is that sometimes and in the farmer model, many less farmers thought that it was actually possible to do that, even with good management. So that's another incongruity between the two models that some of the researchers in New England are focusing on about seed longevity in the soil and how you can manage your weeds in order to keep lowering and lowering that seed bank so you have less and less weed pressure over time.
Well, I've had some farmers who were convinced that it was possible,
Yeah.
but they said you must not be lazy and really focus on every weed you see and walk on your field in the evenings and pull out every weed and before they set seeds. So
yeah. Yeah, I had a farmer who said he went out and hand pulled, velvet leaf every time he saw it because he wants his son and daughter-in-law to not have to do that when they get old.
yeah.
So.
Marleen, someone asked if perennials are less of a problem in the Netherlands because of all the plowing you mentioned.
What was a lesser problem?
Perennials?
Oh, perennials. No, perennials are also a large problem here. And that's why the farmers are a little bit scared of applying no-till systems because they think that plowing controls perennials. So many of the farmers I talked to had 1 or 2 perennial species in their fields, and they are trying to find certain solutions. We also have a joint research project now on the perennial weed control to see which strategies work for these species. Yeah, but perennials are definitely a problem here.
Okay. And then somebody asked how best to do systems approach weed management research with emphasis on biological insect management, tillage effects on soil microbes and disease organisms.
How best to do that?
So, any suggestions for how to do systems of approach on weed management research?
On weed management and then considering all kinds of other areas?
Mm-hmm.
Okay. Yeah, well, it actually depends on the question you have, I guess. You can say, okay, well, I want to investigate this system, to do systems research, but I think you always start with a certain question and then see how you can answer it. So it's a bit hard to answer this question without more details on the research question you have.
Okay. Right. And then there's also some production questions, and one was about quackgrass. If you have any suggestions on how to manage quackgrass.
With the quick up, do you know this type of machinery?
I don't think so.
With it?
Can you describe what it looks like?
The quick up, it is a machinery from Denmark originally, and quick up means crabgrass up. So if you use this machinery, it brings all the roots of the crabgrass on top of the soil and leaves it there to dry. That's something farmers usually use. And then a more long-term strategy, I think, would be to have a cover crop. For instance, Luzern. I don't know if I pronounce it right, but it's a 2 or 3 year cover crop which you can mow. A lot of the farmers in our research, both in the previous research group but also in the current research group, said they were using cover crops very effectively. Those are the 2 things that comes to my mind right away.
And then another question to follow up on the cover cropping somebody asked is, how many years would it take a cover cropping to have an effect on an average weed seed bank?
Well, farmers, it also depends again on your tillage system. So if you have a no-till or reduced till or inversion till system, it differs a bit. But I think 1 year would already have an effect because you have 1 year of less or no seed production, and most seeds in the soil will not live for many years. Only certain species, seeds from certain species will survive for many years. So the biggest reduction in the seed bank is already the first year. So 1 year will be already effective if you can prevent weeds to produce the seeds by growing the cover crop. So.
And then there's another question on your first study you talked about, Marleen. Is the profit from being a short-minded, or I guess a short-minded farmer greater than the profit from the longer-minded farmer? Does the higher value crop make up for the cost to control more weeds?
No, in the end it doesn't. There are some farmers growing high-yielding crops on every field in 1 year. So those are the ones that we identified as the short-term oriented farmers. While the other farmers are also sometimes growing these crops, but they are not adjusting their crop rotation just to be able to grow this crop in this certain year. So they have these crops, but maybe on one field and not on all fields. So they can manage the labor better and have the balance in their system. And in the end, it pays off more because some of the short-term oriented farmers had fields with carrots completely covered with crops, and so they plow it under. So they take a big risk and they also lose a lot of crops.
Okay. I think we covered all the questions.
Okay.
Great.
Unmuted.
Okay,
Thank you,
thank
Patrick.
you. I just wanted to close and thank you all. And thank you all for your questions as well. And I wanted to mention that if you would like to see any of our other recorded presentations on eOrganic, you can find them at the link that's on your screen. And you can find the slides as a PDF handout at the second link, and we'll be posting the recording of this presentation within the coming week. We'd also